This is Chapter 4, Goal 18. At this point, you should know how to graph sine, cosine, secant, cosecant, and tangent. And we are finishing our study of graphing trig functions with the graph of cotangent. The first thing I would like for you to do is go over to your table and fix the typo that I made. Change tan of theta to cotangent of theta. So go ahead and mark through that and change that to cotangent. And I'd like for you to complete the table and then answer questions C and D. And they're very similar to questions A and B under Goal 17. And I will help you get started. So at first this asks for the cotangent of theta when theta is equal to 0 radians. So if you think about the unit circle, 0 radians is on the positive x-axis, and the ordered pair there is 1, 0. We know that tangent is equivalent to y over x, so cotangent, which is the reciprocal of tangent, should be equivalent to x divided by y. And so the cotangent of 0 radians should be equivalent to 1 divided by 0, which is undefined. Please pause the screencast, complete the table, and answer questions C and D. So double check your table, and then what happens to the graph of cotangent at 0, pi, and 2 pi radians? And you'll notice that in all three of those, cotangent is undefined. So we can say that the graph of cotangent has vertical asymptotes at those 3 points. If you'll go ahead and place vertical asymptotes on your graph at 0, pi, and 2 pi. And then plot these other points. So pi over 4, 1, pi over 2, 0, 3 pi over 4, negative 1, 5 pi over 4, 1, 3 pi over 2, 0, and 7 pi over 4, negative 1. So you can see that cotangent falls to the right. So what do you think the period of cotangent is? It's pretty simple to see here. We have asymptotes that are at 0 and pi, and 2 pi. So the asymptotes are always pi radians apart. So this function repeats every pi radians. Cotangent has a period of pi. So just like tangent, the formula for period is pi over the absolute value of b. What do you think the amplitude is? Well, again, just like tangent, there really is no amplitude, there is no max, and there is no min, because the function has a range from negative to positive infinity. But also, just like tangent, at the quarter and 3/4 marks, cotangent has a point at positive a and at negative a. Then the domain of cotangent is similar to tangent in that we do have all reals, but those all reals are broken up with asymptotes. So let's look. If we were to draw a period to the left of 0, we would want to go pi radians to the left to negative pi. And then if we divided this period into 4 equal parts, the midpoint is where our x-intercept is. And then we would be at positive a and negative a, or positive 1 and negative 1. If we drew an additional period to the left, we would go pi radians to the left again and have an asymptote at negative pi over 2. So I can see that this function is all reals except for odd multiples. I really shouldn't say odd multiples, and I will say integer multiples of pi. So negative pi over 2 is an integer, negative 1 is an integer, 1, 2 pi is an integer. So at integer multiples of pi, cotangent will be undefined. And again, if you look over at our coordinate plane that we drew at the ordered pairs, cotangent, because it is x divided by y, will always be undefined when y equals 0. And that's along the x-axis of the unit circle, or 0, pi, 2 pi, 3 pi, 4 pi, and so on. One thing I do want to point out are one of the differences of tangent and cotangent. Cotangent is undefined, where tangent equals 0. If you look back at the table for tangent, tangent was equal to 0, at 0 and pi, while cotangent is undefined at 0 and pi. Remember that the reciprocal of undefined is 0, the reciprocal of 0 is undefined. Also, if you'll notice that cotangent falls to the right, where tangent rises to the right. Also recall that tangent has vertical asymptotes at odd multiples of pi over 2, where cotangent will have asymptotes at integer multiples of pi.